Okay, guys, now that we've got GLUT set up on our machine and we're ready to rock and roll, we're going to start putting together a very simple application using GLUT as our Windows interface, interfacing to OpenGL so that we can do something in 3D. So what are we going to create? It's going to be a very simple application that's got a colored cube, and the user will be able to interact with his arrow buttons to rotate the cube around.
Right.
Now, I'd like to go ahead and point something out. As we're now beginning to take a look at the use of several window interfaces with OpenGL, there's going to be a few functions here that we are going to reuse in the upcoming videos when we take a look at SDL, WX widgets, etc.
Right, we're going to be creating the exact same application using 4 different window interfaces.
That's right. So it would be counterproductive for us to explain those functions when nothing internally changes at all over and over and over.
It just doesn't make sense.
So we're going to explain these particular functions in this video in depth. But when we get over into the other videos, it's going to be copy and paste. Okay?
Right.
So if you want to just kind of jot this down in the back of your mind, the functions I'm talking about are going to end up being named Established Projection Matrix, Init GL, and we've got Draw Scene. Now, there's a couple of other functions as well, such as display FPS and check keys that we're also going to use. But there's going to be changes with the different window interfaces.
That's right. I mean, 3 of those functions are going to be, there are certain just one-liners that need to be changed.
Right.
So if there's changes, of course, we're going to be telling you what has changed.
Exactly. But I just wanted you guys aware ahead of time that just in case you wanted to quickly skim through this particular video and jump forward to SDL or WX widgets because that's what you're working with, you're going to find that the deep descriptions of these certain functions are going to be left out there. We'll just mention, hey, go back to the GLUT video and take a look at it there.
That's right.
All right, so Joel, let's go and get started.
All right, so here we are inside the IDE. So let's go ahead and create a new project. So File, New Project. And let's create a Win32 console project. And let's call this, GLUT Demo. Let's go ahead and press OK. And let's switch over to Application Settings. And we want a console application. We'll just create an empty project.
Right.
Because we're going to be creating everything from scratch here. So let's go ahead and press Finish. And so, let's see. We have an empty project right now. So let's go ahead and create our source file. So add a new item. And let's go ahead and call this our GLUT Demo. And we're just going to be using one source file for this. Of course, if you wanted to, you could divide this into multiple files.
Sure.
But in this case, we're just going to work with one file here. And the first thing we're going to need to do is, as we saw in the intro video, include our header file.
Right. So glut.h is going to need to be included.
That's right. So gl glut.h. And we're also going to define a few constants at the top here, just to give us a little bit more flexibility so we don't have to dig through the code to change, like, the window width and height.
That only makes sense.
Yeah. So let's create a constant GL size. And remember, this is GL size I. This is a type defined inside of the OpenGL headers that allows us to have multi-platform types, data types, excuse me. So let's go ahead and create a window width. And we'll just equate this to, let's say, 500. No. And a window height equals 500. So there we have it. And now let's go ahead and create our main function, our int main. So let's go ahead and go int main, and we're going to get argc. I mean, if you've done much Windows programming, or any programming, this should be really, really familiar to you. Basically, we're just creating our main function that returns an integer and has 2 arguments, an int argc, the number of arguments passed, and an array of character pointers that says what was passed to us. So inside of here, we're going to need to do a few things. The first thing is initialize GLUT, because that's what we're using here. So GLUT init, and we're going to pass it. As you can see here, we need 2 arguments, an argc-p and an argv. So let's pass our argc, which was passed to us, and our argv. And you'll notice I'm passing &argc because it needs the pointer to that integer.
Right.
Let's throw in a quick comment here, just saying initialize GLUT, just to be clean. So let's go ahead and initialize our display mode to use double buffering.
Yes, because we do not want flickering.
No, flickering is bad.
Yes, it is, especially when it's only like 2 lines we're dealing with, one for setting it up and another one for just swapping buffers.
Yeah.
I mean, come on, it's not like it's tons of overhead.
So let's go ahead and say GLUT init display mode.
And GLUT_double.
GLUT double. And again, if you wanted to use single buffering, glut single.
Right.
But don't.
Exactly.
So let's go ahead and create our window. So we have our window ID equals glut create window. And let's pass it, let's say our OpenGL demo. Something like that. Let's call it OpenGL cube demo, just to make it more interesting. And again, we're storing the window ID just in case we want to do other manipulations to it later. But in this case, we'll just leave it like that. So in case we need it, if you wanted to use it in other functions, you can make this a global variable if you wanted to, so that when we call certain glut functions, we could pass that to it.
That's right.
Let's go ahead and reshape our window. So we'll call it glut reshape window and pass it window width and window height. So that'll reshape our window. By default, it's going to modify the last window that was created. So in this case, we just created a window, so we can go ahead and resize it because it knows which one we want to modify. So now let's remember, for glut to work, we need some sort of display function callback.
Right, because we're going to end up passing into the main loop.
That's right.
And it needs to know what to call.
Exactly. So let's go ahead and do our glut display func.
We talked about that in the introduction to this VTM.
Right. And we'll call our display function draw scene. So that'll do all the drawing. Actually, let's go ahead and define the prototype for that function.
Okay, sounds good.
So let's go up here, and that's going to be a GL void draw scene. And it doesn't need any parameters, if I remember correctly.
That's correct.
So we'll go ahead and implement this in a few minutes, but let's go ahead and finish the main function first.
Okay.
Let's see. The way we're going to do this here is by default, the display function is only going to be called if a refresh is needed. I want it to be actually updating constantly. So we have we need some sort of way to have it constantly refreshing the window. So what we're going to do is create a timer function and have the timer function force a redisplay. So what we can have, so let's say you have an animation in your scene. Like if you're working with most first-person shooters or any game, you have a frames per second that's going on. Mm-hmm. And that's because it's being refreshed constantly.
Right.
So that we have very, very smooth animation. So what we're going to do is call a glut timer func. And what this allows us to do is over X number of milliseconds, call a certain function. So in this case, the first argument is there's 3 arguments to this. Number of milliseconds between calls, which function to call when the timer reaches, and then a parameter that you can pass to that timer function.
Right.
Which I simply usually set as 0, but you can use it like if you want to pass certain parameters to the timer, if you so wanted to. So we're going to say every 1 millisecond, go ahead and call that. So that means that we could be up to 1,000 frames a second if we wanted to. But because of the refresh rate, you usually can't do that.
Exactly.
Unless you actually manually turn it off.
Then we're going to create a function called timer loop. So
right.
That's what we're going to call here.
And then, of course, we're going to pass just 0.
Yeah.
And we'll go ahead and create... Let's go ahead and create that timer loop now, just so we have it. Mm-hmm. Let's see here. Let's go up here. And let's create our GL void timer loop. And we'll pass it our int value. Now, it may seem trivial, but it's very important that you name it exactly the way it's expecting. When you pass timer loop into the glut timer function, it's expecting a function that has a void return type and it accepts 1 integer as its argument. It needs to be exactly the same, otherwise this function will fail. So be very careful about that. Now, let's go ahead and finish the main.
You sure you want to do that?
Yeah, just real quick.
Because the next things we're going to add into the main loop kind of tie into how this whole thing works.
That's true.
So we can go ahead and put the timer loop in there, and then the viewers are going to be ready for what's going to happen next.
That's true. When we do call the glut timer function, this is only going to be called once. So right after I call this, 1 millisecond later, this guy is going to be called.
That's right.
But after it's called once, the timer isn't going to continue. It's done. It's done with its task. So what we're going to need to do is call glut timer function again. Func, I can do it. Passing it 1 millisecond, timer loop, and a 0.
And in essence, we've just created our loop.
That's right.
Because now this is going to keep happening.
Yep, it's going to happen over and over again. And when we look at SDL, you'll notice that that's a constant loop, so we don't need to do a timer loop like this.
Right, it's just the way GLUT is.
Right. And also, what we're going to need to do, remember, I said we need to force a redisplay. And remember, we have our draw scene function, which we're going to create in a minute. but you never want to call your draw scene manually. You always want to use GLUT's way of calling things because it waits until the proper moment before it forces a redisplay. There is a sequence which needs to be kept in place. So what we're going to do is inside of GLUT, there's a GLUT post redisplay. So this may not happen immediately, but when it is ready, it calls the draw scene function. So something just like that. In a minute, we'll make changes to this when necessary.
Okay, so now we have a functioning loop in place that's going to continue to do a refresh.
Right. So what we need to do at this point, there's only two more things we need to do. Call GLUT main loop. So, of course, remember, after we execute this line,
we never
come back. But since we are returning
an int,
let's go ahead and just return
0. Yeah. Cool.
Excellent. So there we have it. Let me just go ahead and put this as a note here. It never gets here. I like putting that there just so if someone else reads the code, they go, oh, okay, it never gets there. That makes sense. So at this point, let's go ahead and create our... let's see, which function do I want to create? Let's go ahead and create the draw scene function.
Okay, sounds good.
Yeah. Remember, let's create a very simple demonstration here. We won't create the entire code for it, the cube code, until in a few minutes, but I want to go ahead and make it so that this is a functioning piece of code so we can test it out.
Sure.
So let's go with GL clear, and we're going to do a GL color.
Guys, at this point in time, while Joel is typing this, I want you to kind of think back to the introduction. And remember the flowchart that was laid out that showed you how the whole process of an application worked using OpenGL, and there's our GL clear.
That's right. And notice in this one, remember in the intro, we only had a 2D example, so we only cleared the color buffer bit. Now we're actually dealing with 3D, so we want to make sure that, we clear the depth buffer bit as well. So we simply OR it with the GL depth buffer bit. And then what we're going to do is clear the model view matrix. So let's go ahead and switch over to our model view matrix. So our GL model view. And do a GL load identity. Let's see, something like that. And then at the very end, do you remember what we need to do? I do.
At the very, very, very end.
After we're done, let's go ahead and put our draw cube
where we're going to have our block. And then, of course, we're going to have to do a flush, GL flush.
We need to flush it out.
And don't forget to swap those buffers. We're using double buffering, so when we do the GL flush, everything's been rendered to the back buffer.
Yep. And as we mentioned before, this is one of those functions that after we explain it once, we really won't be explaining it again.
That's right.
But this is one line that, depending on which window interface we use, will be changed.
That's right.
So let's go ahead and put this in as this line is modified in
different
other window interfaces.
Ooh, that's good enough.
So with that should work. Let me go ahead and check this out. It seems like everything should be working. So let's go ahead and compile this. So 0 errors. Let's go ahead and run it. And we get a perfectly awesome black screen. Sweet. Another thing that I want to do, since that is set up, I want to create an initialization function that I usually just call initGL, and that basically sets up the core things, prepares the state of OpenGL, if you will.
Right.
And I usually...
And we talked about this as well, if you think back. Since it's a state machine, you may have all sorts of things that you want to establish at the very beginning.
Right.
It's a good place to do it.
Exactly.
You don't want it in the loop getting hit over and over and over.
Yeah, because that just slows it down, and there's no point in it.
There's no point.
So let's create our initGL function, and I'm separating it into a separate function just to make it a little bit easier, because there is quite a few things that I want to do here. And I'm going to pass it the width that I want the screen to be. I can spell, really.
Yeah, I was about to say. Joel!
What are you doing? Sorry, initGL. And what we're going to do here is, there's a few things actually that we need to do. We need to establish the projection matrix, because in this one we're not using 2D anymore. As we talked about before, we have different projections that we can use.
Right.
And in this one we need to create a 3D projection. And we're going to have to do that at some point at the very beginning. So, in fact, that brings up another function that I want to create called the establish projection matrix. So let me go ahead and do a GL void establish. Oh, I did it right. Projection matrix. And again, we're going to pass it the width and height, so width and GL size height. And inside of here, I'm going to first set up the viewport size. And since we're passing the width and height, we're going to pass it 0, 0, the width, and the height of the viewport. So it occupies the entire area of our window. And this is, at first, it's going to default to whatever window size you've created. But if we trap the, if we call back the sizing of the GLUT window, then we're going to need to call this as well, so that when the window is resized, the viewport is changed. So I'll set that up. We're also going to need to set the matrix mode over to GL projection, since we're now going to modify the projection matrix. And let's go ahead and load the identity so it switches back to its default, whatever that may be. And here's the one simple line of code that we need. GLU perspective, so we're calling the utility function GLU perspective. And we're going to pass it the field of view, which is going to be at 45 degrees. Some people like to use 50 degrees, 45 degrees. It's whatever you like. And then, of course, the aspect ratio, which is the width over the height. And since we're past the width and the height, let's go ahead and do a width divided by height. But notice these are both integers. So if we do a width divided by height, it's going to cast it back to an integer.
Exactly.
So what we need to do is first cast these over to a GL float. And GL float. And let's pass it the near and far depth. In this case, our scene it should work with a 0.1 for our near clipping plane and a 200.0 f for our far clipping plane. So that should be it for our established projection matrix function. And initGL is going to call this one. So all we need to do is do establish projection matrix and then pass it whatever was passed to us. And there we have it. Done.
Nice.
And another thing we need to do is actually initialize OpenGL like we were talking about before. Set up the initial state. So the first thing is we're going to set the shading model to GL smooth, just so we get nice smooth shading on our object, on our cube, even though it is a flat object. Then we need to set our clear color, as we did in the introduction. We're going to set it to black as well. And a lot of you may be wondering why I always put a 0.0f at the end. This simply denotes that it's a floating point number. I can just do a 0.0, but this simply reinforces the idea that it's a floating point.
That's right.
And let's see, we also want to enable depth test. So let's go ahead and do a GL enable depth test. So now we're actually doing depth tests and utilizing the depth buffer.
That's because, we need to make sure that we draw our faces in the right order.
Exactly. And then we'll do a GL depth func, which is going to specify how we determine which faces to draw first. And this is saying that if it's less than or equal, draw the face.
Right.
So LL equal.
Very important.
Very, very important. Now, this is an unnecessary addition, but what we're going to do here is do a GL hint, which is saying, hinting to the OpenGL engine, if it is possible, go ahead and do something. And what we're going to do is do a GL perspective correction hint and do a GL nicest. And what this is saying is, for the perspective calculations, go ahead and use the nicest calculation and hence the slowest calculation possible. So we get really nice perspective deformation. And finally, we'll enable GL perspective nicest. Wow, you know what?
There you go.
That was just a lot of typing.
Yes, it was.
So now that we've created our initGL and established projection matrix, let's go ahead and go back down to the initialization here. And after we've created our window, let's do our initGL and pass it the window width and window height that we had before. And let's go ahead and compile this just to make sure it runs all right. You'll notice it looks exactly the same, but it now has the initialization that we were talking about before. And at this point, since we've got all of that set up, let's go ahead and create our main drawing code. Let's go ahead and draw the cube out.
Okay.
Now this is going to be a lot of code, but it's really not that complicated. So just kind of grit your teeth and bear with us. So we have our GL begin, and we're going to be creating 6 quads here for the front face, back face, bottom face, top face, and all that.
Exactly.
So let's go ahead and do a GL quads, and let's go ahead and end that off. First thing we're going to do, let's set the color up. So let's have a 1.0. Let's set this to some shade of something. That's 1 full intensity with red, partial intensity with green, and 0 intensity with blue. And then let's go ahead and create. We're going to need for our first quad, which is going to be going to be our top face.
So we're going to need 4 of these GL
vertices.
That's right.
And since this is going to be our top face, it's going to be on the Y plane.
Okay.
Actually the XZ plane, if you will. So all the Y values are going to be the same.
Right.
And we're going to be doing this in a clockwise fashion. Let me just go ahead and type this out, and then I'll explain it. Negative 1.0f. And let me just copy this 4 times. So there we have our 4 little faces. And notice these 4 vertices right here, 4 components are never going to change because they're all going to be on the Y-axis. And let's go ahead and switch. Typically, if I'm creating a cube, I've done this so many times that I just need to look at it and I know what it's doing. But basically, you'll notice that it's starting out with, let's see, this is, should we go ahead and create maybe a diagram for this or something?
Where do you want to make the, okay.
Yeah, this is all good. So we basically have our X component in the positive.
All our viewers need to do is just draw out a simple grid.
Draw out a simple grid, and it's
we're working
really
on a
easy
2D grid. I mean, we're working on the YZ grid.
Right.
So.
Oh, the XZ grid.
Or the XZ. That's what I meant.
Right.
Y stays the same.
And so it's really simple. If you just look at it, bam, there it is. And what we need to do is copy this guy 5 more times, and then we'll have our little thing. So 1, 2. Yeah. I can count really. So 1, 2, 3, 4. 5, 6. Now let's go ahead and label which ones these are. So this is going to be the top face, our bottom face.
You missed your B.
I noticed that.
That was great. You didn't have to change it though.
Hey, I just can't help it. Our back face and then our left face. Which is our last one again?
Right face, I would say.
Right face. So there we have it. So let's go ahead and, for our bottom face, it's going to be all these guys, but just negative. That's really difficult. And then our front face, for our front face, it's going to be all of the Z components are going to stay the same. So if we look here, all of them are going to be facing closer to the viewer. Mm-hmm. And then these guys are simply going to be, let's see, 1.0. These 2 would be negative. And that's it.
Okay.
And let's actually, just to make it simpler, more simple, switch these guys to negative. And that's it. So you really, when you're doing this, you just need to remember one of the components. For like the top face, do it once and then just negate all the Y components. And then for this one, do it once, Z components stay the same, and then negate all the Z components.
That's right. Now, at this point, we're using GL Color 3F, and we've got the red little bit of hint of green color.
Oh, right, for all
and basically it would be used for all, but this is just a reminder how OpenGL is a state machine.
Right.
If your intent was to leave it that same color for all of them, you don't need to define
it so many times.
That's right. So in this case, let's go ahead and change the colors up.
All right. Let's go ahead and switch the bottom face to something like a green. Something like that.
Okay. And
maybe for this one, we'll make it red. And for this bottom one, let's make it yellow.
Okay.
Something like that. All right, now I totally don't remember. Okay, I think I was on the left face.
Yeah, the
left face is blue.
Yep.
What should the right face be?
Right face, red and blue, set to 1.
Okay.
Yeah.
So many numbers. All right, for the left face, let's go ahead and knock this guy out. Remember, this one's going to be for negative on all the X components. And this one's going to be 1, 1, negative, negative, and then negative, negative, something like that.
Okay.
And then let's go ahead and copy all of these guys, paste them in here, and then just invert the X component for all of these. And I think that should be it if I didn't make any errors.
We'll find out in a second.
We will. Whoa! Okay, now this brings up a hugely important thing. By default, remember, we reset the model view matrix. So now the camera is essentially at the very center of the world. Mm-hmm. And if you look at our cube here, let me just go ahead and exit this out. We're wrapped around, the cube is wrapped around 1, 1, and 1.
Right.
Around the origin. So the width of the cube is 2 for each of them, and it's wrapped around it. So what we're going to need to do, let me just get rid of my minus sign, is go back in the Z-axis a little bit. So let's do a GL translate F and move the camera back. So 5.0. So we're moving in the X0, Y0, and in the Z we're moving back 5 units, so we can actually see the cube. So go ahead and compile that and run it. So now we can actually see our red face. That's cool and all.
There is a cube there, but we're looking straight on
So it's just like we're looking at one face, which is kind of not cool. So let's go ahead and exit this out. Let's rotate the cube just a little bit. So let's do a rotate F in the Y-axis and in the X-axis. So let's see. First is the angle. Let's do maybe 45 degrees. And this is in degrees, mind you. So let's see. In the X-axis. And we'll do 45 degrees in the Y-axis as well. So there you have it. Ooh. There we have an actual cube. Ooh, excellent. Now let me go ahead and exit this out real quick. And you'll notice if we did not do this GLU perspective, let me just for demonstration, let me get rid of this established projection matrix thing. You notice we get a completely blank area because it defaults to an orthographic projection. And in this case, of course, we have a 3D object, so we need to do that. We need to have a perspective one. And let me just go ahead and uncomment this. And let's say I change the field of view to like 80. You'll notice we'll get a very distorted looking cube. So it's essentially making it so that we can see more areas. The cube essentially becomes smaller, and then it's going to be more distorted as we look out into it. So I just thought I'd point that out for people that wanted to know. So let's go ahead and change this back to 45, which is a more natural projection. So with that, all we need to do now is start creating it, making it so that we can actually modify the cube. So at this point, we're going to need to add in keyboard handling functions. And inside of OpenGL, this is pretty interesting the way we have to do this. Since everything is using callbacks, as in this one, we have a display function callback. We have keyboard handling functions as well that we need to use callbacks for. And we're going to handle 4 of them because the default ASCII characters that you see on your keyboard, all the letters and numbers, those are regular keyboard functions. But the arrows which we want to use are under OpenGL considered special keyboard functions.
Right.
So we're going to have 4 different ones that say the up, down of the regular keyboard and the up, down of the special keyboard. So we're going to have 4 here. The first one's going to be our keyboard func. And then we're going to pass it our display callback for that. We'll call that keyboard CB for callback. I'll paste that and do a keyboard up callback. And essentially how we're going to handle this is inside the keyboard callback and the keyboard up callback, it's going to set an array. So we're going to have a keys array full of booleans that says whether or not a key is depressed. So inside our loop, we can simply say key escape. Is it down or is it up? So let's go ahead and create the other 2 functions, the special ones. So our special func. And we'll call this keyboard special CB. Let me just copy and paste this. And our keyboard special up callback. And like I said, we're going to need a Boolean array of 255 characters for all the ASCII characters. So let's do a bool keys with 255 elements. And when it's false, that means that that particular key is not depressed. And when it's true, it's going to be depressed. So let's go ahead and create those 4 callback functions that we need. So let's go to right about here and start creating the 4 callback functions. Now, this does seem like a repetitive task, and unfortunately, when using GLUT, this is kind of a drawback, is that there's no other real way to just check an array and say, is this particular key depressed? There are functions to check the modifier keys. I believe it's GLUT modifier keys, and then you can check whether the shift or alt or control is held down. But for the rest of the keys, you have to use some method similar to this, especially in a real-time application.
Right.
So we have our GL void keyboard callback, and it's requiring 3 arguments, an unsigned char of key, as long as an int x and an int y, which is saying where on the where was the mouse when you pressed the key. And all we're going to do is say our keys array of this element, keys key element equals true. Because we just depressed, say we press G, it's going to call this function. So let's go ahead and copy this function and do almost exactly the same thing, but for up. And up is simply going to set that particular element to false. And let's go ahead and do it for the special keys as well. So let's copy this. And let's go ahead and say special callback. And we're going to set this to true. We're modifying the same array, which means that we could get... some people like to have two separate arrays, one for the special and one for the regular. In this case, I'm just going to use one since I'm only requiring certain keys, and it doesn't have any conflict. So let me go ahead and... Actually, let me copy this one. Having a hard time typing today for some reason. That's okay. And false. So let's go ahead and compile this, make sure everything works. And you'll notice it says, cannot convert parameter 1 from unsigned car to int. And that's because when we're dealing with special characters here, the key is actually going to be an integer. So let's go ahead and change that over to an integer. Let me not delete all my code. Wow. Okay, so let me recompile that. And let me go ahead and run this through real quick. Let me put a breakpoint here. Go ahead and press F5 to go into debug mode. And you'll notice if I'm going to press H on the keyboard here, H, and it just called my callback function. And currently in that array element, the key, notice, is ASCII 104, and it's going to set keys, which is currently set to false, to true. So, think now that element is true, and inside my timer loop, I can actually check and say keys with H as a parameter. If that is true, do something. Mm-hmm. So let me go ahead and stop this. Let's actually create a function that is used to do all our key checking. So right above our callbacks here, let's go ahead and do a GL Boolean called check keys. And what the goal of this function is to do any key, exactly, check the keys and see if we're pressing arrows that we need to rotate it or whatever. So inside of here, let's go ahead and let's see. Let's first check to see if the escape key was pressed, exit. And when check keys returns a true, the way I'm interpreting this is if it returns true, that means that the user wants to exit the program. If it's false, then continue executing. So what we're going to do is say if keys, escape key, whatever that may be. In fact, by default, the GLUT H header file does not include a definition for the GLUT of the escape key. So we're going to create one in just a second. Well, we're going to call this GLUT key escape. So if that one is depressed, let's go ahead and return true. Otherwise, just return false and keep on going. And we're going to actually do that right here inside of the timer loop. We're going to call this particular function. Actually, I'm sorry. Let's go ahead and create the GLUT key escape definition. So let's go ahead and go to the very top here and create a simple define GLUT key escape, and we'll define this to 27. So whenever it reaches this, of course, it's just going to replace that name with 27. So let's go back down to our timer loop, if I can find it. Timer loop right here. And we're going to call if, let me do it actually at the very beginning, if check keys. So if it returns true, so if equals true, or just call the function exit and return with a 0. Now, you may notice a simple problem here. Notice check keys is defined after timer loop. So at this point, it may be better to go ahead and put all the definitions of these functions at the very top so we can use them interchangeably without needing to worry about the order. So let me go ahead and... Of course, the simple solution is just to take this function
and move it
up. And let's actually do that just temporarily, just to prevent.
You didn't want to go through and have to do all that.
Yeah, I was like, I could do it, but all that typing.
Big.
Yeah. So let's go ahead and build this guy, and I get unsafe mix of type bool, right? Because it's a GL boolean compared to a bool, and true is a bool. So let me just do this because that's simply saying that anything that's not 0 is true. So check this out. If I go ahead and run this and I press escape, the program now exits, which is very, very cool. So with that, let's go ahead and start doing the keyboard control for the rotation. So let's go to the very top and create two public variables that simply say what the rotation for the cube is. So let's create two floats, two GL floats called cube rotate x, and let's initialize it to say maybe 25, or let's initialize it to what we had a second ago. For the rotate, we had 45 degrees in x, and for the rotate in y, we also had 45 degrees. And you can change that to whatever you're happy with. So if we come down to here, let's go ahead and change the degrees. And again, this is in degrees, not in radians. So that's very, very important to keep in mind. For some reason, OpenGL has always stuck with the using angles instead of radians. Not quite sure why, but that's just what they do. So let's go ahead and switch this over to a rotate in x, because remember, this is the axis of rotation that we want here in x, y, and z. So in this case, we're rotating around the x-axis. And here we want to rotate around the y-axis, so like so. Let's make sure this all works. It's always good to test your application. Everything's still cool. So let's exit. Now, if we go back into our check keys area, when a user presses the left arrow, right arrow, etc., we want it to rotate in the correct directions. So let's go ahead and do the following. If keys, and these are actually defined, a key left, which is the left arrow. So if that one is pressed, we want to rotate it around the y-axis. And again, let me just go ahead and run this. The y-axis is running up and down here. And in OpenGL, by default, the y-axis is the world up, and the z-axis is going into the screen. So when we press the left and right arrows, we want the cube to rotate around like so. And around the x would be like that. So let's go ahead and exit this out. So if the left arrow is pressed, let's go ahead and change the y. So minus equal, where'd that h come from? And minus by a certain amount, let's say 1.0f. In fact, let's go ahead and create a constant up here. A constant GL float speed. So how fast we want the cube to rotate. And just 1.0f. So that we can just come in here and say, because we're going to be using it 4 times, and if we want to change the speed at any point, we just need to change one constant.
Sure.
So let me go ahead and copy that out. And you'll notice I'm not going to be using an else if, simply because I want to make sure that you can press multiple keys at the same time and be able to, of course, if you hold the left and right arrow keys at the same time, it's not going to move. But,
right.
But
and the up and down arrow keys.
Right. But still, it is a lot better. This is something that is really cool using this method instead of handling a callback, using inside of here handling it, because when I'm handling in this way, I can have multiple keys held down, and it will still respond to all of them without any callback interruptions. So let me go ahead and copy this 2 more times, and we have our key up and our key down. And this is going to be for our rotate X and our rotate X. So let me go ahead and run that. So let's see if this works. Ooh.
Ooh.
So there we have our actual cube. So I didn't actually screw up anything. Isn't that something?
It's looking good.
Now another thing I do want to add is change the title here so that it displays what frames per second we're running here, because that is kind of important, and that also shows off how to actually get the current time of the operating system, so we can manage the speed. Say if you're doing animations in a game and you want to make sure that the animation is 30 frames a second, we want to make sure that it's running at the right speed. So that's very, very important. So let's go ahead and create a display FPS function. I think we mentioned that at the very beginning that we're going to create that. So let's go ahead and exit this out. And let's create a right before the draw scene function. And we'll call this our GL. We don't want to return anything. And all this is going to do is display the frames per second by simply changing the title. And this is where stuff gets interesting. There is a function inside of GLUT called GLUT get. And this allows us to get various attributes inside of GLUT. And one of the things it allows us to get is the current elapsed time. So what we're going to do is create a long called last time, and do a glut get, and we simply pass it glut elapsed time. Ding, 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 ding. So this gets the elapsed time since X minutes ago. So since program execution, we'll know exactly how much time has passed. We're going to go ahead and create this function, this variable right here as static. So this gets executed on the first call, and then every time we can refer So let's go ahead and let's see. Right. So basically what we're going to do is get the last time, and then on the next call to this, get the new time. Oh, you didn't even tell me that I misspelled it. How awful.
From where I'm sitting, it all looks good.
And then we simply do a new time minus last time, and that's going to give us the amount of time since the last execution of this function. And what we're going to basically do is, remember, frames per second is the number of frames executed per second. And since glut get is going to return the time in milliseconds, all we need to do is take somehow store how many frames have passed by. And we're going to use another static variable called loops, or we can call it frames if you want. I'll go ahead and call it loops. That says how many times this function has been called, so we can accumulate frames. And this display FPS is going to be called at the very end of the draw scene function. So we'll do a display FPS, and what this allows us to do is every time this function is called, that means we've just drawn another frame. So if we accumulate and calculate how many times this function is called, we essentially are calculating how many frames have been drawn. So if we go back up here, every time the display FPS is called, we want to actually increase the number of loops or frames that have been actually executed. And then we can actually calculate it simply by taking frames, loops, and divide by the total amount of time that has been elapsed. However, the problem is that it can be executed like on modern machines. This function, this display FPS, could be called so fast that the number of milliseconds between calls is actually 0. And this can cause a divide by 0 error, which is not so good. So what we're going to do is say if the new time minus the last time is greater than 100 milliseconds. So we wait to calculate the frames per second until we've already elapsed 100 frames. So we've elapsed 100 milliseconds, excuse me, and then we say, okay, how many frames have I drawn in that 100 milliseconds? And then I can calculate the frames per second that way. So what I'm going to do is say, inside of here, let's calculate the new frames per second. And this is really, really simple. All we need to do is convert the loops to float so it can give us an accurate representation, and simply say new time minus last time. So how much time has elapsed since the last time this area was executed? And then since this is in milliseconds and we want frames per second, we convert it over to seconds. So that is our new frames per second. And we could just directly display that, but you'll notice that if you just pass it this way, just send out the new frames per second, the frames per second can change really, really quickly. So a common thing to do is take the last frames per second and average it out so we get an average frames per second. So let's go ahead and create another static variable called FPS so that we can store the frames per second of the last run through. And then we can simply calculate the new frames per second by saying frames per second plus the new frames per second, and then simply divide that by 2.0f so that we get the average of the 2 frames. And now we need to change the title, so let's create a simple character array of 80 elements and do an sprintf. Sprintf, if you've never seen this before, all it's going to do is instead of printing onto the screen, it's going to do a string printf into, say, title, and it allows us to format our string, which is really, really convenient if you need to do like what we're doing here. So we can say we want to print our title into title, the variable called title, and then let's call it OpenGL demo, and we want to pass in the frames per second here, so we can just do a %f, end that off, and pass it the variable that we want here. So something like that. And let's go ahead and set the window title. And again, since we only have one window, we don't need to pass the ID or set the ID. We simply do a glut set window title.
And just pass it.
And just pass it the title.
Right.
And finally, what we need to do is make sure the last time is going to equal the new time, so the next time we come through, we know exactly how much time was executed.
Right. And reset loops.
Yeah, we need to reset the loops to be 0. Let's see. Is that everything? Okay. Identifier not found even with argument independent lookup. And this is because we
need another include.
Yes, we do. We need to include stdio.h. stdio.h.
And that does it.
And that does it. So let's go ahead and run this. And look at that. We're running at around 80 frames a second, sort of. But notice there's a whole bunch of little guys at the end here.
Yeah,
and
we could format that just a little bit
better.
Yeah,
just make it so that maybe it shows 2 of them or something.
Yeah, sounds good.
So let's go ahead and come down here, and we can just do a 0.2. Run that. I can do it, really. And that sets it down to have only 2. Much, much better. Let's go ahead and exit that out. Let's see. Is there anything else we need to add? I'm trying to remember if I'm missing anything. Am I missing anything?
I don't think so. We've actually accomplished the task.
Yep, we have accomplished the task. I'm just trying to make sure I haven't forgotten anything. Nope, I think I actually got everything.
It's a very good job, Joel. Almost no mistakes.
Almost no mistakes, except for a few typos.
So as you guys can see, GLUT is really, really easy to use.
Very, very simple. I mean, like in the intro video, we only had like 50 lines of code and we created an entire triangle.
Right.
And in this one, we have what? Let's go down to the very bottom here. 200 lines of code, a few minutes of work.
Well, and you could probably say it's a little bit over 100 lines. You take out all of the blank lines.
And the comments and all that
And the comments, exactly. So, yeah, GLUT's really easy to use, but it can be a bit limiting on power depending on what it is you're trying to create.
Yeah, it is. And like in this case, we had to use a lot of callbacks just to accomplish something that seems very simple to do. But at the same time, it's really simple, and I definitely recommend it if you're doing simple tests for things.
For sure. And with that, that's going to wrap up this video. Thanks a lot.